Hello students! Today we will look at one interesting concept, and that is coin toss. Suppose a coin is tossed at random. Can you think about its outcomes? When a coin is tossed, it can land in one of the two possible ways, either heads up or tails up. Now suppose if I ask you a question, what is the probability of getting a head even before actually tossing a coin? Note that here we have not yet performed the experiment actually. We are talking about theoretical calculations of probability of getting a head when we toss a coin. This question tells us to calculate the likelihood of coin landing head up. And to answer this question, we'll have to find out two things. One, possibilities of getting head up, and second, total possibilities. Let's find them. We know the one and only way of getting a head is if coin lands heads up. This is the first thing which we wanted to find this probability. Now the second thing we need to find out is the total possibilities. Here, as we can see, there are two possibilities, since it can be either heads or it can be either tails. No other way is possible. The number here in denominator shows actually all possibilities for this event. This 2 covers all possible outcomes since there can be either head or tail and any other outcome is not possible. Thus, this fractional number tells us that probability of getting heads is 1 out of 2, that is 1/2. Now if I ask you to tell me the probability of getting a tail without actually tossing a coin, can you? I guess it is easy for you now. Correct, the logic is same. So just like heads, there is only one way we can get tail is if coin lands tails up. And there are two possibilities in total, that is heads or tails. Thus, probability of getting a tail is again 1/2, that is 1/2. Now look at both the events. Landing a head and landing a tail have same probability in our example. And since probability tells us the likelihood of the event occurring, such events are called equally likely events. Thus, equally likely events are those events where their possibilities of occurring are same. Recall that event is a group of all same outcomes in an experiment. So, as there are two possible outcomes here, heads up and tails up. Thus, a group of all heads up clubbed together is one event and tails up put together is other event. Also note that here we have not actually tossed the coin. I mean, we have not actually conducted the experiment. And so it is the theoretical probability. Okay, so now coming back to our event of heads up. In our experiment of tossing a coin, event of getting head can occur once. So we can say that number of favorable outcomes is 1. And total outcomes possible are 2, that is heads and tails. Thus, in our fractional probability, the numerator is the number of favorable outcomes to the event and the denominator is total number of possible outcomes. This formula just tells how many possibilities out of total possibilities are there. But students, what if there are 10 throws of a single coin? Since the events of getting heads and tails is equally likely, can we say that we will get heads 5 times and tails 5 times for sure shot after 10 tosses? This might not be true. We might get 4 heads and 6 tails, or we might get 7 heads and 3 tails, or some other. So what does this half tell us? It tells us that if the process of tossing a coin is repeated many times, say 1000 times or 10,000 times, then we will get approximately the same number of heads and same number of tails. But the requirement of repeating an experiment has some limitations, as sometimes it may be very expensive or unfeasible in many situations. Like in our example of tossing a coin, repeating experiments or carrying out many trials is easy and possible. But how about repeating the experiment of launching a satellite in order to calculate its probability of failure or success? Or how about repeating the phenomena of an earthquake in order to compute the probability of a multi-storied building getting destroyed in that earthquake? In such cases where the repetition of an experiment is difficult and needs to be avoided, we make certain assumptions. We assume that the outcomes of experiment are equally likely in all such cases. Yes, students, we make assumptions of outcomes being equally likely and then calculate its probability. Such a probability is called as theoretical probability. Another example of equally likely outcomes is throwing a dice once. What are the possible outcomes? We may get 1, 2, 3, and so on up to 6. Each number has equal possibility of showing up. So all outcomes are equally likely. Or we can say that equally likely outcomes of throwing a dice are 1, 2, 3, 4, 5, and 6. And theoretical probability of each event in the experiment, that is getting a single number, is 1 upon 6. Here 1 is the probability of getting one face and 6 is the total probabilities since we have 6 faces. But the question is, are the outcomes of every experiment equally likely? We will see in our next video.